and welcome to a little video about Target 6C. Alright, let's get started with a little bit of histograms. You might remember these as bar graphs when you were learning them for the very first time. Histogram would be the more appropriate term to use. Okay, so our first histogram on the left-hand side is about a group of students that was surveyed to find out how many social media posts do you make a day. So, the question I have here is, how many students made more than one post? Right, well, I have these bars which tell me the frequency of things happening. So that actually tells us that there were 2 students that made 4 posts. One that made 5, 3 for 6 and 7 each, one that made 8, and 3 each for 9 and 10. Let's add that all up. 2 plus 1 plus 3 plus 3 plus 1 plus 3 plus 3. That's 16. Let's check out the next histogram. The graph below represents the number of siblings each student in a class has. What I'd like to do is find the median number of siblings. So I'm a little bit more visual. So what I like to do is create boxes by extending the line from the frequency all the way across. So kind of using my y-axis to separate my x's, just like on a regular graph that we usually use. Okay, so now I have these boxes all cut up, and it's going to be easier for me to find the median, which is the middle. So first, I'm going to cross off some boxes from the left-hand side. I'm going to cross off all 6 of these zeros because it's all the way on the left. I know that that's not going to be the middle. Well, if I cross off 6 from one end, I need to cross off 6 from the other. So let's do that. Okay. Now I'm getting closer to the middle, so I'm going to go slowly. I'm going to do 2, and then 2 more, 1, and 1, and then 1, and then 1, and I'm left with 3 siblings being the median. Next, I have a question. Well, first we have the histogram with students being surveyed about the length of their names, how many letters they have. The question here is, how many students were surveyed? Well, once again, let's use our frequency to find out how many students had the letters in their names. 3 students had 2 letters in their name, 2 had 3, 3 had 4, 2 had 6, 2 had 7, 1 for 8 and 9 each, and 4 students had 10 letters. Let's add it all up. 3 plus 2 plus 3 is 8, plus 2 plus 2 is 12. 8, yes, 12. 13, 14, plus 4 is 18. I don't know why I just doubted my addition skills. Shame on me, Ms. Gumin. Shame on me. Another thing that we expect you to be able to do, other than interpret histograms, is to create them yourselves. Now, I stole this problem from Delta Math, so it says like click and drag to make a rectangle, but we're just going to go ahead and draw them ourselves. This is going to be a histogram about the temperature in Spring Mountains in New York City over a certain period of days. Let's see. So the first thing I'm going to do is I am going to do my best to create these intervals on the temperatures axis. Okay, I'll do it, maybe if I could type it in, it might be a little nicer. 30 through 39, 40 through 49, 50 through 59, and 60 through 69. So those are our 4 categories. And now I'm going to use this awesome tool here on OneNote to create my histograms. It's going to look good. All right, so there are only 2 days between 30 and 39. Okay, so let's make the bar right here. Let's just do that. Oh, look at how nice that looks. I'm just going to connect them all to make it look pretty. Okay, so there's the first one. From 40 to 49, we had 16 days. Okay. So we're going to go all the way up to 16. I'm just going to make it like this. Okay. From 50 to 59, we had 26 days. Wow. Okay. And they're having some nice temperature. It is cold here in Chicago. All right. 60 to 69, 8 days. So my last little bar right there. Okay. Here's a nice little histogram. If you notice, it almost looks like a little pyramid. Low on the bottom, hitting a peak, and going back down. Well, that is actually called a normal curve. Let's talk about those. So we have normal curves in our standard deviations and our normal distributions, but they can only be called normal in certain circumstances. So the one on your left is normal because it has its mean, which is in the middle. Well, yeah, that's it. It has its mean in the middle. Boom, there it is. Now see how it's tall and narrow? This would actually tell us we have a low standard deviation, which is going to come in handy very soon when we fill this out. Well, a standard deviation. This is not a normal distribution because it actually looks like it has 2 peaks. And that doesn't really make sense. I can't really have 2 means. It's a distribution, but it's not considered normal. All right, here's another normal distribution. It's kind of more squished than the first one we saw, and that's actually totally fine. It still has its peak, its mean, right in the middle. This is called a high standard deviation, when it's a little flatter and squishier. This one over here on the right-hand side, that's not normal because its peak is on the left side of its data. It should be in the middle. Lastly, we have another another normal curve, and it has its peak in the middle. It's not as high as the low standard deviation or as squished as the high standard deviation. It's somewhere in the middle. It's still normal. On the right-hand side, however, we have a mean that is right there, more on the right-hand side. It's not in the middle. It's not normal. All 3 of the not normal distributions are still distributions and can represent data. They just cannot be labeled as normal. Now, these distributions can be looked at in standard deviation form. Standard deviation means how many deviations, how much difference is it from the mean? How much difference in data do you have from the average? Now, our standard deviation has several different categories in it. It has the distance of 1 standard deviation from the middle. So here's the middle. And 1 standard deviation can happen to the right in the positive direction. So it could be lower, or, did I say low? I meant higher. And this one is on the left, it's lower. Now, each of these sections contains a certain amount of data. And let's write that down. If we are 1 standard deviation above average, that's 34% of the data. That should fall there. And you know what? Another 34% falls 1 standard deviation below the average. Let's continue. 2 standard deviations away. Now in total, from 1 standard deviation to the left and 1 to the right, we have 68% of the data. That's 34 plus 34. From 2 standard deviations to the left and 2 to the right, we actually have 95% of our data. When we break it down, in this little section, we have 13.5% of the data. And over here, we also have 13.5% of the data. All right, so that's 95% of all the data. Okay, well, I still have a couple more sections left. I have between 2 and 3 standard deviations. So that happens right there. Oh, that was supposed to be a black. Me and my color coding. All right, there it is. And there it is. Whoops. Let's move you here. There you go. Okay. So, when we have the information between 3 standard deviations to the left of the mean and 3 standard deviations to the right of the mean, we have a total of, whoops, sorry, that was an email if you heard it, 99.7%. Wait, 0.7? Yes, 0.7. It's not 100% of the data. What? I know. Okay, well, how much percent does it contain? It only contains 2.35% of the data. In this little section. And as you know, there is leftovers. It's not pure 100%. We have 0.3% left over that we need to split up, giving this 0.15 of a percentage on each side. So how do we use this in real life? Well, let's say we got a piece of data that was between 0 and 1. Well, we would know that 34% of the data falls in this category of between 0 and 1 standard deviations from the mean. Now, if we're talking about something like battery life, that means, if we're in this section, we're actually better than average. And 34% of these phones with these batteries are 34% better than the average. However, there's also 34% that are worse than the average. Okay, well, how about if we had a phone within 1 to 2 standard deviations? So their battery life lasted even longer. Well, we're super lucky, and 13.5% of people with that phone will have a battery life that lasts that long. However, we have equally unlucky people who will have their phone batteries last even less. It keeps going, guys. It keeps going. What if we have a phone that's just completely incredible and lasts like a gajillion bazillion hours? I know that's not possible, but you know, let's just use our imaginations. Only 2.35% of people would have a phone whose battery life lasts that long. And on the other end, we're going to have people whose phone lasts like a second and then dies. It gets better and worse. If we have a battery that lasts, I don't know, Googleplex in infinity amount of battery hours, we're only part of 0.15% of the group. Very few people have a phone that lasts that long. On the other hand, we might have a phone that just doesn't charge at all, right? It's just dead forever. And 0.15% of the people with this phone and the battery life will have that dead phone. So this is what we would call a lemon, if you've ever heard that term. It just, for some reason, it doesn't work. All right. So, I hope this helps you understand some statistics that you see posted around the interwebs. And this is going to be useful, so I am going to I'm going to have to scroll back and forth. You know what? Why would I do that? Let's just move this problem down. Psh, okay. Alright. Let's talk about this problem about some standard deviation. When Brooklyn commutes to work, the amount of time it takes her to arrive is normally distributed with a mean of 54 minutes and a standard deviation of 4 minutes. Using the empirical rule, what percentage of her commutes are between 50 and 58? All right. Okay. So here's our curve. I'm going to do my best to draw it. And we are just going to use our... Oh dear. Oh dear, no, go away. I can't. I'm just gonna copy this. I tried. I really did. Okay, there's just a blank graph. Okay, so normally distributed with a mean of 54. Our mean is in the middle. So I'm going to label this as 54. I want to use a different color, purple. 54. Now, our standard deviation, what is it? 4 minutes. So we're going to go up and down by 4. I think the easiest to do is up, so let's go up by 4. So that's 58, 62, 66. We're not going to go further than that. Let's go down by 4. 50. Oh, I know that's all we really need, but that's fine. I'm just going to finish labeling it. 56. 52. Okay, I want to know how much of our commutes are between 50 and 58. Let's see where that ends up. 50 is here. Excuse me. 58 is right there. And let's refer to our standard deviation. That's 34 and 34. 34 plus 34, let's write that down. 34 plus 34, that's 68%. So 68% of the time, Brooklyn will arrive in nowhere. It doesn't say where she works. It just, to work, she will arrive to work in 50 to 58 minutes. And that's actually pretty good to know when you're commuting. Something to think about. Let's continue to this problem, which I'm going to drag down. There it goes. Okay. The amount of a certain brand of light bulb lasts... Let's start that sentence over again, because clearly I'm missing words there. The amount of time a certain brand of light bulb lasts is normally distributed with a mean of 1,600 hours. I'm going to highlight that because I know we're going to use it. And a standard deviation of 70. So we're going up and down by 70s. Using the empirical rule, determine what interval represents the lifespan of the middle 99.7% of the light bulbs. Aha! That number sounds familiar. Where does 99.7 happen? Between 3 and 3. Aw, shucks, we're going to have to fill out the whole table. I say it like I didn't know, but I knew. Okay, here is our standard deviation. The mean is 1,600. We used purple last time. I feel like orange now. So 1,600 goes right in the middle. And the standard deviation is 70, so we're going to count up and down by 70s. Let's do it. 1,600 plus 70 is 1,670. Plus 70 is 1,740. Plus 70 is, okay, just double checking my math, 1,810, right? Yes, okay. Can't believe, I am doubting my skills today. Shame on me, guys, shame on me. All right, let's go down by 70. 1,600 minus 70 is 1,530. 1530 minus 70 is going to be 1460, right? 60, 70, 80, 90. Yes, okay. 1460 minus 70 is 1390. I'm gonna double check because I'm, doubting my skills today, and that's okay. It happens. Yes, calculator said I'm correct. Fantastic. All right, so that's it. We found out 99.7% is from -3 to +3. That's 99.7. Look at how chunky that is. So our lifespan goes from 1390 to 1810 hours. And that's about it. All right. If you have any questions about this, please don't hesitate to contact either myself or your teachers. Otherwise, have a good rest of whatever day it is for you. Bye.